Okay. Good morning, Professor. Good morning, fellows, classmates. Today, I would like to give a brief talk on my final practicum. The topic is feasibility study on the applicable zero energy building solution, which is considering the embodied energy and the environmental issue. The topic is quite so long, but I believe after my presentation, you will know what I would like to present. In the following presentation, I will focus on the introduction, some background information of my study, the assumption and my methodology, and finally, my study. There are three types of study I'm going to present. One is a low-waste building, another one is high-rise building, and also the community. Finally, Q&A. So about the background, I would like to share why I choose this topic. I remember in December, I shared my electricity bill with my friend. My friend also lived the same size of apartment as me, but different location. The place I live in is a new built apartment, but for him, just an old apartment. But my electricity bill is only half of him. So I'm so interested. If the building envelope is well built and with well consideration, it will save my money and save energy. So I'm interested in save my money. So I choose this topic. And also, I can apply all the study I am in the energy management into this study. Recently, net zero energy building is quite a hot topic. And I wonder if it is possible to have self-generation energy can fulfill the whole building operation. So I need to find it out. Finally, I would like to prepare in my future development. Why this topic is so important for me for future career development. That is, the building energy consists of 39% of global gas emission, and also the 36% of total energy consumption. So let me give you some background information of the net zero energy building. What is the net zero energy building? That is very easy to consider. The building self-generated energy can fulfill its building operational energy in the annual basis. But now many people will challenge the net zero energy building. Why? Because it will destroy the natural habitats. And also, many building is built in the remote area. So people did not consider the logistic cost or transportation cost, or even in the future, the people live there, the community energy costs. So now I would like to present the feasibility of the deep retrofit on the building rather than the new build building. Another one is when we're facing the high-rise building, the load floor space and the volume ratio is very low. So that means it only equipped the limited area for me to generate the renewable energy. So it is a problem. But the net zero energy community may help in this case. About my assumption, first of all, let me introduce a term that is embodied energy. What is that about? That is the life cycle energy minus the operation energy. So what is that? Life cycle energy, that means from material from cradle to grave, what the energy involved. But we have the sufficient data to analyze the operation energy of the building. So we minus it. That is the embodied energy. Another one is the solar insolation. When we are on the Earth, different locations will receive a maximum insolation from the solar. And normally, it is the panel tilt angle is equal to the latitude angle. So we just take this assumption. Also, during my computer simulation, many parameters in request, I can't get the optimum one because let's say the R value, I need to have a 60, but the maximum I can choose is 40. So I picked the maximum one in my study. Finally, it's about the heat pump and extract. most likely they need to take the air source from outside, but the temperature of the air source is fluctuated. I just take it in the constant in my calculation. So what I'm going to do is we will study the energy analysis of these two projects, two buildings. And I have already studied about the net zero energy building measures, which is include the external wall, windows, roof, lighting, natural gas, and some pump and motor. We apply this technology know-how in the improvement. Finally, I will use the computer simulation to see before and after the energy performance. About my findings, I'm going to present two main projects, which is in the British Columbia. One is the Rosewood Village. And for these two projects, the information I got on hand is mainly we rely on the information which we study in the energy management 6 and 10, because it's facilitate more detailed information to me and let me to do a detailed energy analysis. And about the Rosewood Village, it is quite a large area and three types of building, which is a low-rise building, just 1 or 2 stories. That include 1 office and 33 townhouse and 2 apartments, which are labeled in different color. I make use of the data provided from 2015 to 2018. And also I take 2015, the data as a baseline to put it in the Q-sum analyze to see what is the energy performance during these 4 years. And this curve show the result. The curve, the slope is going up. That means the energy consumption is increasing per the year base. That means we need to have some improvement on the energy saving. Otherwise, it will consume a lot of energy. And I also make use of the equations based on the information provided, like the building envelope, the equipment, the finance model, and build the energy model. So simply, we can see this table. The total annual consumption is 2,700 something megawatt hour. Is a little bit higher. So in the time being, I would like to do the improvement. So the improvement, basically, what I applied, what I have learned and studied in the net zero energy building design. It includes the rooftop, above grade external wall, below grade wall, ground floor, and the floor type, and glass door, window, and the ratio of window and wall, and some of the furnace and heating system. Because as you can see, the main energy consumption is in the space heating and the domestic hot water. So after we make the improvement through the simulation of the equation, we can see the energy consumption is lower about 40%. Now it's 1,673 megawatt hour. And after we make the improvement on the energy consumption, we need to have the renewable energy generation. Here is the picture. I would like to go to construct the solar panel. And the blue color is the townhouse, and yellow is the office. And also, I will construct a car park canopy for obtain more solar energy power. And the green one is the apartment. So here is the performance analysis. After we have the retrofit, and also I have calculated the embodied energy, which is 30% of the conventional energy consumption. And we will know that after all the calculation, this project can have the net zero energy and also have 232 megawatt hour extra. The negative is I can generate and supply the energy back to the grid. Another project is Sunnyside Minor. It's a high-rise building, 10-story, which is located in the West Vancouver. And similarly, we do the same on this project. And the total energy consumption on the baseline, that means I haven't done anything. That is 1,324 megawatt hour. And after we make the improvement, it can lower about 60%. It's 300 megawatt hour. Also, we done all of this by the eQuest. But it only provides me a limited area, only a rooftop. So we can't do a net zero energy building in this high-rise building. So we can see annually, we need to have 350 megawatt hour from the grid annually. So what should I do? So I study a concept of net zero energy community. That is, make use of different type of building. They have their self-generated energy and consumption, and share the information through the smart grid to reallocate the demand and supply and contribute all the buildings throughout ecosystem. So in this study, we can see our building is Sunnyside Minor here. And there are many houses we can make use, and also there's a fire station and the police station. And I also make use fire station data, which is from the Fort St. John, which is a net zero building, which is in Fort St. John. And I make use of the energy density and also the generated energy density and put in the model to see if we build every building with the shared energy, can we do the net zero energy community? So here is what I have done. And the high-rise building, yes, we can do it. But if we combine with the townhouse, police station, fire and rescue depot, and the government building, and some of the parking lots and the entropy, we can get very tightly the net zero energy consumption, and also have some suffers, but very little. So as a conclusion, it is feasible to have a retrofit net zero energy building, which can eliminate the concern of the greenfield development, destroy the natural environment. And also, we also encounter the embodied energy, which is also is lower compared with a new build building. And the low-rise building, of course, is easy to achieve. But the high-rise buildings, if we can get the support of the cooperative net zero community, we also can achieve the net zero energy building and the community. Thank you very much. That is all of my presentation.
Question from you.
Yes. Now, about the simulation, we all know that it's very challenging to using the uncompleted information. So how do you know your result will match the reality? Yeah.
Okay. Thank you very much for your question. I think first of all, we need to have a reliable baseline. That means a reliable foundation. You are right. Even I get all the information from very detailed information from 6 and 10, the project data. It is not sufficient for me to build a very perfect model. Somehow I need to extract some of the data and with my imagination. But I also have the baseline. How I do the baseline is I need to make sure my simulation from the eQuest, which is matched with the data information provided. Maybe I show you I have record because I can't do a eQuest simulation here. But last night I assume somebody will question my study and my working. So I did a video. So a moment. No problem. Maybe I say first. And what I do is after the eQuest simulation, I obtain the energy consumption like this. So this is what I did in one of the apartment building in the Rosewood Village. After the simulation, it will output the energy consumption in the year base. So So here is the annual base. And I copy all the data, all the table to my spreadsheet here, but with different unit. But I can use the Excel to calculate different unit in terms of the unit which is fit with the data provided. Like this one, the gas consumption, which is gigajoule here, is about 1,700. But we have two buildings, so it's times two, it's 3,400 something. That is what we have do in here, 3,400 something. So I validate every building energy consumption like this to make sure the foundation of my data is correct. Yes. I would say probably not, because first of all, now I'm studying only a residential building, and the main energy consumption is the space heating and the domestic hot water. But if I apply in some manufacturing, like the injection molding manufacturer, the main energy consumption is no longer the space heating, it's for the machine energy consumption. And second, as I read a study that mentioned the energy consumption in cold climate area is different from the hot climate area. And now I just take the case, but just a very basic case in Vancouver. That is a cold climate or cold and moderate climate area. So in the hot climate area, maybe it will turn on the air conditioning all the time, especially the commercial building. So the energy model, I need to recalculate to see if it can apply. But up to that moment, my study only focused on the cold weather area and the residential building. Thank you. Yes.
I got one question about the EPRESS.
Yeah.
So you use EPRESS when you make the model, you can maybe just use some Google Map and measure the dimension about the building, or you can use the AutoCAD file. That's the two way you can install the model. Which one you choose and why?
Actually the area, I mean, if I use the Google Map, is try to capture the floor area. But in my eQuest, I seldom use it because in my data sheet, it provides me the floor spacing. Because for floor spacing, that define, let's say the Sunnyside Minor is a 10-story or 11, one is below ground, is 11-story building. And even I calculate through the Google Map, it doesn't work. So I make use of this data from my data sheet on the simulation of the eQuest. And for SAM, when I calculate the solar panel on the rooftop, I do a very simple simulation. I would say I will take a Google Map measurement as a reference. I haven't do any AutoCAD because because my broad view of the study is try to see if it is feasible. But of course, I have some gap or some buffer for my study. If I need to go in further detail, especially when I need to study this building, how I can do the deep retrofit design, how I need to do the renewable energy design, I need to do so. But in my study, it doesn't. And for the same, the system model, system analyze modeling, I haven't done it because as my consumption and many net zero building, even the rooftop is flat, but if we need to consider the latitude angle and the tilt angle, somehow they will modify the rooftop with the with the pitch angle, which is a little bit or similar to the latitude angle. Okay. Thank you very much for your question.
Thank you so much. One question about so you didn't consider any like solar hot water heater at the roof. You just consider like putting the photovoltaic panel. Yes.
Yes, yes.
Nothing like heating like water, like a collector, water collector, stuff like that. No.
Actually, I think it is a very good idea, but because I don't have enough time in just 3 months, because I need to review the model. I know the solar water heater will have a higher efficiency compared with the solar panel, because for the solar water heater, it can achieve 33% or more efficiency compared with the voltage panel. It's just 22 maximum, somehow like that. So I do believe that in the cold climate area, if we can apply the solar water heater like the collector, which will have a better performance on my study. But in the hot area may not be. But
Actually, one idea I was thinking like you can compare later on, not for your project. That was of course a very good project that we did. You can compare whether we use like for a high-rise building, instead of using photovoltaic or electricity, we use like a panel, solar hot water heater, like a collector, water collector. Could they just supply heat for water and compare these two buildings? Let's say if instead of using photovoltaic, you just use water collector to for heating water, and then see which one is, of course, more economical, or I mean, cost efficient from that point of view. See which one is better for the building. That's an idea, of course. Just,
thank you very much,
yeah, thank you.
Professor.
And thank you very much for
Thank you.
presentation.
Thank you.